Hi guys, in this video I'll talk about static and dynamic memory allocation. So there are two ways of allocating memory. One is statically allocated memory. This would be, for example, int number equals 5. So these are variables that are statically allocated. That means the memory is allocated when they are declared, and when they run out of scope, they are automatically freed up for us. Now, dynamic memory allocation is different. That is manually managed. So we are in control of creating it or allocating it and then deleting it when we no longer need it. So an example here is, for example, pointer equals new int. New dynamically allocates memory, and whenever we have new, it also requires us to delete it. Otherwise, we have a memory leak. Now I can go to that address, store 5 in it. When I no longer need it, I delete it. So I control when I need to allocate the memory when I need it and when I delete it. Now, why would we deal with this hassle if we can just do it simple? So turns out we always want to use static memory allocation when we can, but there are ways when dynamic memory allocation is useful. So to give you an example, let's create a prototype here, create array. And in this example, I use dynamic memory allocation with arrays. So let's provide an implementation for create array at the bottom. And here I create an integer array of 3 integers, 4, 3, and 8. And I return that memory address of the very first integer, essentially the memory address of the array. Now in my main function, I want to call the create and output the array. So here I create an integer numbers. So this is a pointer to an integer, so it's a pointer to the array. And then I call the create function. So this will execute it, create the array, and then return the address. And then I loop over the integers in that array, and I output each one, and each one surrounded by square bracket. And then here I do a closing square bracket, and at the end add a line break. Now let's run this, and what do we expect? So it calls the create function, creates the array of 4, 3, and 8, returns the address, and then stores the address in the pointer that I have here. And remember, pointer and array variables, they're essentially the same thing. So I just use array syntax here to make it simple. I basically output that for I, 0, 1, and 2. So I would expect some output like 4, 3, and 8, but I get something completely different. And the reason for this is that the array variable was statically created. So when I created it here, it's a local variable. And then at the end of the function, local variables get deleted. So this array no longer exists. The memory is still there, but it's really up for grabs. There could be anything in it. So when I access it here, that array no longer exists. So in this case, what I want to do is dynamically allocate it so that I'm in control when it gets deleted. So what I do here is I use a pointer. I still call this array, and I do new int, and with the brackets, I create 3 integers. Now this is dynamically allocated, so it doesn't automatically get deleted. I control when it will be deleted. And then I assign the values. Index 0 was a 4, index 1 was a 3, and index 2 was a 8. And then I return it. And now in the main, I can output it, but since it's dynamically allocated, I want to be sure that I delete it. Now I call the delete keyword. It is an array, so I use the brackets. And in this case, delete. I use the pointer up there, so this pointer is called numbers. But the pointer essentially is just an address to the array, similar like this. It's the same address in another variable, so they point to the same address. So if you think in terms of house, there's one house, multiple people have the address. This person here has the address of the house. and this person has an address of the house. And I can tell either person to clean up the house. It doesn't matter as long as the house is cleaned up. So in this case, I use the numbers person up here to clean up the house. Now let's run this and see what we get for the output. Now we get what we expected, 4, 3, and 8. So it was created here, and since it was dynamically allocated, it is not deleted at the end of the function. The address is returned, and then we can operate on the array. And when we no longer need it, we use the delete keyword with the brackets to delete the entire array. I hope this gives you some ideas or some idea how dynamic memory allocation works. And thank you for watching.